So hello everybody, and welcome back to another episode of DevOps for Everyone. I'm your host, Joe Bignell, and I'm joined by Ramon today. How you doing?
Hey Joe, you're doing pretty good. Thanks for having me.
Not a problem. It's the first time I've had a unicorn on, so I'm very, very happy that you're here. Should be a good one. Ramon, this has been advertised. People, I'm sure, know about the business. You've been all over the news. But do you want to just give us a brief introduction as to who you are?
Yeah, so my name is Ramon Gil. I am VP of Observability at Timescale. I'm based out of Barcelona. So before Timescale, I worked for another company that maybe some folks are familiar with. It's New Relic, which is a company that plays in the observability space. And so my current role at Timescale is we're building an observability solution on top of Timescale DB. And I can get into more details into that. And basically, my role is I'm overseeing product engineering and go-to-market for PromScale, essentially PromScale, which is the name of the product that we're building on top of Timescale DB.
PromScale, okay. So VP of Observability, it's not a job title you come across very often. How would you break it down? What's your day job?
Yeah, I mean, VP of I'd say this is not a role that, as you say, you would typically see in a company. And it's actually very specific to Timescale, because what I do is, so I'm maybe better described as VP of Observability Products. So I lead product engineering and go-to-market for Timescale's observability products. And that's essentially PromScale. So my work is I work cross-functionally across different groups inside Timescale to build and grow usage of PromScale, which is an observability backend powered by SQL, since it runs on top of PostgreSQL and Timescale DB.
Mm-hmm. So your role then, would it encompass both kind of sales and technical engineering?
Yeah, not really sales. Actually, we don't have a sales team at Timescale. We're all product-led growth. So it's people come, they use our products. We have open source, so our products are open source, and then we have a cloud offering. And so a lot of people know us because of our open source products, and then they decide they don't want to manage the products themselves. So Timescale, maybe I can give a little bit of context on that. Timescale builds Timescale DB. PromScale as well, which is a more recent product, the one I'm working on. But traditionally, Timescale, it's built Timescale DB, which is a time series database that is built on top of PostgreSQL. And I think that is a really important thing, because technically it is an extension to Postgres. So it's Postgres under the hood. So you leverages these extension capabilities that are provided by Postgres, and you have full access to all Postgres functionality. And Timescale DB, what it does is it makes Postgres better for time series data. So it adds functionality to improve performance and capabilities for time series data. Timescale DB, it's offered as an open source. I already mentioned open source software. It's maybe open core to be more precise, and all capabilities are completely free to use. There is just one exception: is if you're trying to build or offer Timescale DB as a service, then that's not allowed by the license. That is what your AWS, for example, and that's what you want to do, like they do with a lot of databases. You will not be able to do that, because that's the way we make money, basically. So we offer Timescale Cloud, which is Timescale DB, Timescale DB Cloud Service. So it's managed for you, so you don't have to worry about the operational aspect of managing a database at scale.
So has being open sourced and being heavily open source like you are, has that kind of taken away the need for an external sales function?
I don't know that it completely removes it. And maybe as you try to grow into larger organizations, I think having a sales team is useful. But in our current stage, we actually did have a sales team, a long time before I joined the company. And that was at a point where the company did actually sell an enterprise license. So you could take the software and deploy it yourself on your infrastructure. But the company decided to move away from that, and so they gave the product entirely for free. If you want to run it yourself, you can for free. All the features are available, and focus exclusively for revenue generating activities. Focus them on the cloud offering. And there, what we do is just basically try to create a lot of great technical content. Also generate awareness for our open source product that people know us. And I mean, has a Timescale is actually pretty well known in the among the developer community, especially those that are maybe big fans of Postgres. And as a result, with all that awareness, there are people, that want to adopt and say, okay, I need to scale this, but I don't want to manage it myself or have to build an internal team to operate the database.
Yeah.
So I rather outsource that, like they would do maybe with AWS for, MySQL or plain Postgres. They do the same with Timescale, and they get all those time series capabilities on top of Postgres as a result.
Okay. All right. And I mean, obviously we'll get into a demo in a moment, but people can easily just Google Timescale and be able to find much more information on the product and the company as a whole. Yeah.
Yeah. If you go to timescale.com, then you'll find, that's our website. And on GitHub, if you go to Timescale, the Timescale organization, you'll see, Timescale DB there, PromScale is there. So you'll see all our source code is on GitHub.
Okay. And if people did Google Timescale, I'm sure the very first thing that would come up was the amazing funding round that you guys have just been through. So we'll talk about that for a little bit, because it's amazing. I think the numbers, what is it? 110 million that was raised in a Series C, which takes it to over 180 million across a couple of different rounds, which basically means that you guys are valued at over 1 billion, making you a rarity, making you a unicorn. So, I mean, that's obviously incredible. So tell us a little bit about that and what that means for the future of the business.
Yeah. So the first thing is that we didn't really need to raise money. We still had, most of the money from the previous round available. But for us, it just, give us, additional fuel to continue investing, especially in our product and building this data platform for developers. That this is basically what we're building, a solution to allow our customers and the developers at large to analyze data, store large amounts of data and then, analyze it. So we're very focused on maybe what we call more like data intensive kinds of applications, applications that require processing, large amounts of ingesting, processing, querying large amounts of data. And usually real time. So we have a lot of customers in IoT, in Web3, crypto, the kind of customers are typically gravitate towards Timescale DB as a solution for analyzing their time series data. Because time series data at the end, I mean, if you think about it, most of the data is time series data. They have a timestamp, it evolves over time, and you want to understand how that data is evolving, as part of analyzing either for yourself or to expose that to your customers. If you're analyzing, let's say, the crypto market, and you want to see how the different price fluctuates or the different transactions that are made on the different crypto markets. So you could use Timescale DB to store that data and then very quickly plot it, show the trends, on charts on the screen, for your users. Observability data, like what we do with PromScale, is another example. You want to see how the performance of applications and infrastructure is evolving over time, and so it's the same thing. You store large amounts of data and you need to typically query it in real time to understand what the health of the systems are.
You're supporting some really progressive and rich sectors, so I can kind of piece together why the business has been doing so well.
Yeah, I mean, at the end of the day, it's we're going after a massive opportunity for sure. It's time series data. As I said, data with a time component, that is everywhere and is growing very quickly, as I already mentioned. And then the other thing is we're also showing, a lot of traction. We've seen 7 times community growth. By that I mean usage of our community open source products, if you want.
Really, 7 times
in the last 2 years, and 20x revenue growth, right? So that is also, I think, when you combine very large opportunity with a lot of traction, then it's normal that it gets the attention of investors.
Are your clients typically in the enterprise sector or enterprise size?
We do have fairly large customers, but overall, I actually say we've traditionally probably mostly targeted mid-market rather than high-end enterprise. Although we've seen like large customers, because so two things. One is there are very massive organizations use Timescale to be very large, like Tesla, for example, companies like Warner. There are companies like that use, and then some of them then end up using our paid offering. Some of them use open source, and we're really happy that they do, and get value of the product. They also provide great feedback. And then what we do is monetize Timescale Cloud. In Timescale Cloud, we haven't been traditionally so focused on enterprise, as I said. We've been mostly driven by product-led growth, but naturally we've attracted also large customers. Then as we move forward, we can see that developing further. Where we grow our teams to be able to better serve also larger organizations.
So the investment you said that's coming in is going straight back into the product. So what I wanted to know as well, because you're obviously the VP of Observability, I know that your teams, your engineering teams and product teams are distributed globally. So how do you, as someone senior in the business, manage a globally distributed team at the moment? Because, pre-COVID, a lot of companies were very much on site, but now 90% of people are remote. So how are you getting on with managing everybody?
Yeah, you definitely get used to it. A lot of companies have had to go through it. I think for very large organizations, probably a lot harder than for startups and the smaller linear organizations. All that said, I think there are some cultural traits that are important. For us, really important, like transparency and trust. That's actually, it's very hard to work in an environment where you basically don't see people, and I haven't met. I joined 7 months ago. I've only met a handful of nobody. Actually, just one person in my team and a handful of people in the company, because we have not been able to travel. So unless there is a lot of trust and transparency, which also helps build that trust, it's actually really hard to manage and scale such an organization. I think lots of empathy as well. We have people from basically all over the world, lots of different countries, and they have different backgrounds, right, and different ways of thinking and perceiving the world. Even more important today, with what's happening, with Russia and Ukraine, if you want. So there are different people, different situations, and developing a lot of empathy for them. That's actually also really important for especially distributed, remote and distributed workforce. I think that sometimes, it's easy to misunderstand other folks, when communicating via digital channels. So one of our values is assume positive intent. Maybe somebody says something, you are maybe a little bit shocked, or maybe feel like that was not a good thing to say, but rather than maybe then quickly judging, maybe talk to the person, try to understand, assume there is always positive intent. People are trying to do their best, right? And finally, a lot of asynchronous communication, so a bias towards written documentation and asynchronous communication, because with so many people distributed across the globe, it's actually really hard to get them all together at the same time in a meeting to discuss, which again, I don't think it's the most effective. Eventually, sometimes you have to do that and meet and discuss, but you can solve a lot of problems through asynchronous communication and collaboration on a Google Doc, for example. So we do a lot of that.
Yeah, absolutely. So you're in Spain, right?
That's correct. Yeah.
Yeah, so you have engineers in Europe, I guess in America, maybe in Asia as well.
Yeah, so all of that. Yep.
Brilliant. I love it. I think it's the new way of working, isn't it? And then you're covering all time zones as well, so it's even better.
Yeah. It has benefits. It obviously has some challenges, and especially if you're working in the whole way, of communicating. But it brings some benefits, and I think if you adjust and work maybe in a different way that is more effective for that type of setup, then it's actually a very, very positive thing. And then people can also, I think it's good for a lot of people, especially if they like to live in a place where maybe, the opportunities that they will get access to are not the same as if they can access to a global opportunities, companies anywhere in the world. So that's also a plus for people.
Yeah, absolutely. Yeah, I always find it really, really interesting speaking to, someone like you who manages distributed teams and how it works, how you do it versus how other people do it. I don't think there's one way of doing it. I think however works best for you. So it's interesting to hear your point of it. So Ramon, just before we get into the demo, I can see it on the screen here about using OpenTelemetry. And I did share the link to your blog post as well, which people can find on my LinkedIn page. But do you want to just give us a really brief kind of definition of what OpenTelemetry is before the demo starts?
Yeah, actually, as part of this, I have a few slides to talk about OpenTelemetry. I think that's a good segue into this. Yeah, so maybe let's get into it. So I'm going to be talking, as I said, OpenTelemetry, and also, how you can use OpenTelemetry and SQL to better understand the performance and behaviors of distributed systems, because that's basically what observability is about, is typically understanding how systems behave and also troubleshooting them. When there is a problem in production, try to understand the problem as quickly as possible so you can remediate it. This is sort of, a series of things I will cover. 1, 2, and 3 are, slides, but the rest is live demo. So I'll first introduce OpenTelemetry and distributed tracing, and I'll talk about PromScale, which is a free open source observability backend that runs on top of PostgreSQL, as I said before. Then I'll show how you can use OpenTelemetry, PromScale, and SQL to better understand your distributed systems by using a demo environment we've created and that you can get up and running on your own computer, in just a few minutes. So this is, before I start, so this is, where you can find the demo environment. You see this GitHub URL. You can just go in there, and there are also instructions there on how to get it set up. As I said, it will take just a few minutes. And we've also written a detailed blog post, is the one that Joe was talking about before, that covers everything about that demo environment. How to set it up, how to instrument your code with OpenTelemetry, how to query the data and build Grafana dashboards. I'll be covering some of that in this session, but if you want to go and dig deeper, I recommend you check that blog post. Okay, you ready? Let's get started. So for those who are not familiar with it, let's spend a little bit of time talking about OpenTelemetry and distributed tracing. The first thing, so OpenTelemetry, you ask the question, what is it? Okay, so it's a new standard for instrumentation. Instrumentation is adding or generating data, if you want, from your applications and infrastructure, so you can understand their health and performance. So OpenTelemetry is a new standard for instrumentation. It's backed by Cloud Native Computing Foundation, which is the CNCF, the same foundation that is behind projects like Kubernetes, Prometheus, or Envoy. OpenTelemetry was born about 2 years ago after 2 other open source projects joined forces, OpenTracing and OpenCensus. You may have heard of them. And in just 2 years since they joined efforts, OpenTelemetry has become the second most active project, as well as the second with most contributors among all CNCF projects. So only Kubernetes is above it. So OpenTelemetry is well above Prometheus and other very popular projects. Most observability vendors, including us, Timescale and cloud providers, are contributing to the project. Okay, so has a lot of support from vendors and the community at large. So why is there so much interest in it? So the first thing, and it's just a summary, it's a vendor agnostic. So it's instrument once and send telemetry anywhere. So your investment is future-proof. Behind are the days where you had to instrument your system when adopting a new observability tool. Re-instrument it again and again. If you want to change tools, re-instrument your service again. That's not the case with OpenTelemetry. You just instrument once and send the data everywhere. It also opens the door for developers that create libraries, frameworks, and tools for other developers to build their applications to add instrumentation into their source code. So as an example, Kubernetes has started adding OpenTelemetry instrumentation into their code. It's also a standard that includes the 3 key telemetry signals. Metrics logs, those are well known by everybody because they've been used for a long time, but also traces. And traces are really important in microservices environment. And what is really useful here is that all those 3 telemetry signals will share metadata and tags, so you can more easily correlate them. Typically, this is not the case. You instrument metrics one way, logs a different way, traces a different way, and then you end up with 3 different with 3 signals or data that is very hard to correlate unless you manually tag everything the same way. It defines aligned protocol and semantic conventions, and that makes interoperability between OpenTelemetry and other tools much easier. And finally, it provides instrumentation libraries that do automatic code instrumentation. So you don't have to do anything. You just put that library in, assuming the language supports it, and there are a bunch of them like Java or .NET or Node, the Python that support it. Then it will automatically instrument the code, which dramatically reduce the effort to get started, instrumenting your code. Then you can always add manual instrumentation, but you can start with the automatic one, which will give you already a good level of visibility.
So Ramon, just before you go on, you said it's the second most contributed project on CNCF.
Yeah, so the second most active. So active means measures contributions, but also comments and things like that. As I mentioned, it's more than that, but it is the second. I think in terms of just contributions, in terms of code contributions, I believe it may be, I think it's maybe third or fourth, I believe. Wow. The activity, if you measure everything, is second. And then in terms of number of different people, different developers that are contributing to it, it's also the second, just after Kubernetes.
Wow. Okay, that's impressive.
Yeah, in a very short time, it's really, it has a lot of momentum, which is
yeah. That's what I mean. Yeah, the time scale that we're talking about isn't that long.
Yeah. And so, so in today's session, so I mentioned OpenTelemetry covers metrics, logs, and traces. But in today's session, we're going to focus on OpenTelemetry traces. And I think that traces hold, probably a lot of valuable data to understand distributed systems that metrics and logs cannot provide because the data is connected. So, but what is a trace? You'll say, okay. So a trace is a connected representation of the sequence of operations that were performed across all microservices involved in order to fulfill an individual request. Okay, that was a long sentence, but if you look at this slide here, you see you have a very a small example, microservices environment with 4 microservices, and there's a few backends there, databases, and then you see what you see at the bottom. That is a trace, so it's a sequence of operations, and each operation is represented by a span. That's the name of how that's the terminology used in OpenTelemetry and other tracing systems. And so you have a sequence of spans that define its individual operation. So you have, for example, display a full article. Then that display full article method calls calls the news service. Then the news service will get article with comments. Then this get article with comments function calls the query news database, and then it calls the comment service, and so on and so forth, to generate what you see here, basically. This is a visualization of a trace. You see is a sequence of operations. And in here, there are some spans can have 0 or multiple children. You see that, a span that is a leaf span will not have any children, but the other ones, like this one has, this has 1 children. The get article with comment has 2. So it has this tree structure. And then all spans have just 1 parent, except there is one that doesn't have any parent, which is this initial one, and it's called the root span. So that is sort of the entry point to that request. This is just to give you an example. This is a tool called Jaeger, which is a very popular distributed tracing product. And this is a screen they provide that shows an individual trace with its spans. Okay, so you just see a number of spans here. This is the visualization, which is equivalent to sort of what I was showing before, but this is like a real thing. In the demo, we will make heavy use of PromScale and its capabilities. So I just want to take a minute to introduce what it is. PromScale is an open source observability backend for metrics and traces powered by SQL. As I mentioned, it's built on top of program and very rock solid foundation of Timescale DB and PostgreSQL. And as a result, it lets you query the data using full SQL. We will use that extensively, to derive insights from traces in our demo. On top of OpenTelemetry, just because in the demo we will show OpenTelemetry tracing, okay? But PromScale also integrates with Prometheus, for long-term metric storage and analysis. You could get your OpenTelemetry traces and your Prometheus metrics, in the same storage system. So you only need one. It provides you a unified storage. And then it integrates with Grafana to visualize the data, and also the tools like Jaeger, that tool that I showed before, to, in this case, for getting traces. This is a very high-level architecture. I'm going to the details of the computer, but basically this just shows that PromScale runs on top of Timescale DB. Timescale DB, as I said, runs on Postgres to store the data, the telemetry signals that that are sent to it. And it has integrations with Prometheus and OpenTelemetry. So it's you just need to configure something in Prometheus or OpenTelemetry to send the data to it, and same in Grafana. It integrates with Grafana and Jaeger seamlessly, and also because it's there is a SQL database behind the scenes, you can also integrate with any tool that speaks SQL. Okay, so enough for an introduction. Let's start playing with OpenTelemetry, PromScale, and SQL. This is the high-level architecture of our demo system. You can get the demo system from the GitHub URL at the bottom that you see here. It's a password generator that it has been over-designed as a microservices application. So it doesn't make a lot of sense to design a password generator like that, but we did it because it's a simple example and it's good for illustration purposes. So there is this password generator, and it is connected to an OpenTelemetry observability stack that is based on PromScale. It has a load generator that you see at the top, and that load generator is just used, so there is some traces that get generated, and we can look at them. It makes requests to the generator service. Then the generator service calls the upper, the lower, the digit, and the special services to get random uppercase, lowercase, digits, and special characters to build a password, to build a random password. The lowest service is written in Ruby and the rest in Python. This is just to show that you can use OpenTelemetry across multiple languages. OpenTelemetry supports many different languages beyond, obviously, Ruby and Python. All those services have been instrumented with OpenTelemetry traces, and they send those traces to PromScale. As I said, you can get this demo up and running on your own computer. Very quickly, just a few minutes. You just need Docker and Docker Compose installed. You go to all the GitHub repo that you see there. You download the code and just run Docker Compose up, and the demo will come up. You don't need to do anything else to get it up and running. If you want more details, you can check the blog post that I shared earlier for full details. Okay, so now let's look into the demo. Let's check. We're gonna be first focusing on measuring performance. So the first thing is let's look at when you're measuring the performance of a service. As I said, we've instrumented the microservices environment that we have here. So when you instrument a service, there are typically three key metrics that you're interested in. These are the golden metrics, which are throughput, latency, and error rate. Okay, so let's look at how we can get those metrics from trace data. I mean, you could also potentially get them via a metric system like Prometheus. You could instrument your application with Prometheus, but tracing will give us also other values. So, but for now, let's take a look at what we can do with how we can generate those golden metrics from trace data. So first, let's look at throughput. So it's the request rate. So this is very simple query. You have just two charts here that show the requests per second. This is with is doing 1 minute average for this, and this is doing the per second with the average per second of that thing. So basically requests per second. So that one only has more granularity. If we want to look at how the query looks like, this is what it looks like. Okay, I won't get a lot into detail on how the queries are written. Again, the blog post explains that in definitely a lot more detail. But this is just to give you an example and high-level introduction, to the query language. So you have typical SQL queries: select from where, group by, and then order by. Okay, and what it does, so time bucket This is telling you how big you want to make this or how large those data points you want to make them. So this is looking at a 1 minute of data, and this is looking at 1 second of data. So that time bucket is 1 second. The start time is the time at which a trace or a span started, and then it's doing a count. So it's counting all requests. So basically, if we count all requests in a second, we get the amount of requests per second. This is a view that we provide, the span view. This is the one that we query. And then we're looking here, at the last 5 minutes of data. And parent span ID is null. It's just, so instead of looking at all the individual spans, we're just looking at the request, the duration, the number of requests. So if I go back to this, there are some internal requests that are generated here between the app service, the generator and the app service, the generator and the special service, and the other ones. But we're not interested in those ones. We're interested on the user experience here. So we want to see how many requests per second the generator service at the end of the day can generate. Okay, and so that's what we get by doing parent span IDs now. So we just look at root spans at the end, requests at the end of the day. So this is how you would do requests. And by the way, so there's no magic here. This, if you go to edit, this is a standard time series panel in Grafana. And this is the query. This is the SQL query. It's using the SQL, the PostgreSQL data source, because as I said, behind the scenes, there is Postgres, so you can integrate with anything that integrates with Postgres. You get that for free when using PromScale. And so we're just writing here the query that we want to plot, and this is the result. Now let's take a look at. We'll look at request rate. Let's look at latency or request duration. So here. Let me edit this one. So here we're looking, at the distribution, of the request duration, and the same. So we have a query. This query is basically retrieving all the spans in the that match the time filter that is specified here, and this panel will automatically give us the distribution. So we see that there are some that are pretty fast here. We see that some are being executed in a few milliseconds, but the majority of them are rather in here, around in between 1 and, let's say, maybe 16 seconds. We have some outliers here that are very slow, above 30 seconds duration, which is obviously pretty slow for a password generator. This is a histogram, of the duration. So here we see clearly that the majority of the time is spent here. So it's, the duration is usually less than maybe 2.5 seconds. But we have some outliers, again, similar to what we were seeing here. We have some outliers, and especially here, we have ones that are taking more than 30 seconds. That's weird. Okay. So here, we're showing a slow request. Okay. So we're just showing the spans, the root spans that are very slow. So you can think of a root span. The duration of a root span is basically the duration of a request, because the root span encompasses everything that happens, inside that request. And so if you look at it, you can query, because again, there is a SQL database behind the scenes. You can come and very quickly, here query the spans and just retrieve all of them. Maybe this is the top 10, the top slowest one. So we are ordering them by duration, descendant. So the ones that take the longer show at the top, and we just show the top 10. We're also doing this bit of magic here. And this is because the trace ID from OpenTelemetry has some dashes in it. But we're using a trick here that Grafana provides that is actually really cool. Grafana also provides that view that allows you to see a trace, this visualization that I show a screenshot for Yaga that showed the visualization of a trace. You can also do that in Grafana. Okay, and so what we're doing here, we're linking this trace ID that again needs to be without dashes with that UI. So when I click on it, it opens a new tab and it automatically opens that trace, that specific trace, that is low. So you don't have to go and search it or anything. You just, or maybe copy and paste. You just go in here, you click, and it automatically opens the that specific slow trace. And here you can take a look and start understanding why it's slow. So you see most of it is actually very quick. So a lot of them just take like microseconds, but there is a lot of time spent here, seconds. And so that time is actually spent in this digit service, and in particular in the random digit method. Okay, you see here, this is what is slow. It's random. It's consistently random digit that it's slow. So with that information, I could go into the code and check that function. I could go or method, in that or operation, if you want, in the digit service, and that will give I've already narrowed down, very quickly narrowed down, where the slowness is happening. I just can't go there and understand what's happening. So this is durations. The third golden signal. So we've seen throughput or request rates, latency or request duration, and now we're going to look at error rate. So here's the same thing. So we can see where the errors are generated, and we see the majority are generated in the generator service. But this is not surprising, because if an error happens in one of the services that the generator service calls, then maybe the generator service, it's getting an error. So maybe it's not that surprising that a lot of those are focused here. But if we go one level down, we see, a lot of those errors are happening in the upper and also the special service, whereas the lower and the digit service don't seem to be generating an error. So again, we could go in there and check. We could go even farther, because we have, again, SQL. We can run this query that what it's doing is checking, in this case, is counting all those spans that have this status code. It's called status code error. Okay, we also count the total spans. And we are grouping by 1, 2 here, which is service name and span name. So span name is basically the name of the operation. The service name is the name of the service, the lower service, the digit service. And so with this query, we actually have the information. We can compute the ratio of those per service and operation, or span name if you wish, the number of spans that had an error over the total number of spans. So basically, we compute the error rate per span and operation, right? And if we go here, we can actually see that the one that has the most errors is this one. High error rate is the extra process upper in the upper service, and then generator generate. But that is, again, this is the main entry point. So it's expected that most of the errors will bubble here. We need to look one level down. So that's probably the first place I will focus on, try to understand what problem he has. Okay, so we've looked at very good information. I think the error rates, high level error rates, probably some of that information at a high level per service you can get from metric. Going down per operation, that will be typically harder to do with metric. You'll need to add a lot of you need to instrument per operation, which is not very common, but you can get that for free if you've instrumented your service with traces. Let's take a look now at other more interesting stuff. So let's look now more at behavioral stuff, understand how the system is behaving. So the first thing we can do is we can build a service dependency map. So this is a service map, okay, of built from the trace data and using the Grafana node, the graph node graph panel. We can generate this view that basically shows how the different microservices in the demo communicates. Okay, so we have the generator service, and we see it calls the upper service, it calls the special service, it calls the lower service, and it calls the digit service. But then we also see something really strange that definitely not expected, which is the lowest service is calling the digit service. But that doesn't make any sense, because the lowest service is just generating lowercase characters, where the digit service generates digit characters. So that's a way, generating those service maps can help you identify maybe some query behaviors, when maybe a service is calling another service, and it may be something that is expected and works, or maybe not expected, but works as it should, but maybe you didn't know about that, or it'd be like in this case where we definitely don't expect this to be happening. So we should go hit into the lowest service and understand why it's calling the digit service. So again, it's helping you troubleshoot your system. And here is a small example, okay, with just 5 microservices. But imagine if you had 100, okay, that becomes a lot more complicated. And so having this view is actually very useful. And so the way this works, I just show it. This one is more complex, but basically the way the node graph panel works is that you have to provide 2 queries. The first query computes the nodes, so the bubbles in here, and the second query computes the edges, so the arrows that communicate or that join the different nodes. And again, all those details you can find in the blog post. Here we're doing even a little bit more, so we're showing the same information but more in a table view with some statistics. So looking at that, we can see that the upper and the special service actually perform very, very quickly. Okay, that's not where time is being spent. Those 2 services are, the total execution time in milliseconds is just, it's 18 seconds, and the average execution, like the average request from the generator service to the upper service, takes less than 7 milliseconds, and to the special service less than 4 milliseconds. But those ones take a lot more. They consume a lot more time. So maybe if you're thinking of optimizing the performance of the generator service, probably those are the areas where you should be looking at. Let's look at even more interesting stuff, and maybe that will end here. If you want more details, again, check the blog post. So here, actually, let's show the upstream spans. So this is showing upstream spans. So this is or upstream dependencies. This is showing which service and operation is calling another service. Okay, so basically we select here at the top. We have these selectors that allow us to select a specific service and operation, and then it looks backwards to other services. Looking at span data, looks for other services that have made calls to it and builds a representation, a map, so you can see who's making the calls. Why is this useful? Imagine that you have a service that is receiving a lot of requests, but that service maybe can receive requests from tens of different services. So, okay, maybe who's generating that load? Okay, you don't know. So you could use that to actually see, by generating that map, you could use this to look at which is the service that is making more requests to that service that's under heavy load. So you can go and, or maybe there are more than one, you can go there and try to understand why that is happening. So with that in mind, maybe we could take, for example, the digit service, and we can look at who's calling the digit service. And we see here, that the digit service, we saw it before, it's being called by the lowest service, which is really weird. Why is the digit service being called by the lowest service? That is not needed. But if we go back, you can see it's being called by the generator service and the get operation. And then, generator digits generator, that makes sense. They will be there, but it doesn't make sense for sure that the generator lowers generator operation in the generator service is calling, it ends up calling somehow, the digit service. So definitely some bug there that it'll be interesting to understand. Looking at that, you can also see, how many requests are coming, from this versus this, which is, again, a way to understand if you have a service that is under heavy load, a lot of requests, which service may be causing those problems. And maybe just another quick one. So here, downstream spans is a similar thing, but it's the other way around. It's looking, from a service. So if we start with the generator service, this is an entire map. Maybe I can zoom out a little bit to see. So this is an entire map of all services and operations that get called, because all requests start at the generator service. So you can also understand, what the behavior of the system is, the actual behavior of the system, who's calling who. and how often. But then there are also other interesting things. You can look at total execution time by operation. And this one is a tricky one, because if you just look blindly at the time, the duration of spans, then always the generator service, the entry point will be the one that is the longer. The root span are usually longer than, or are always longer than, the spans that the child spans. So, but that is not the case here. You see, most of the time is spent here. So how is this working? So what we do, and I'll show very quickly here, is a query that shows maybe let's move here. It's a query that shows the time is spent, the actual time is spent in the operation. So what we do with SQL is we look at operation A and we subtract the time spent in the children. So basically, operation A is not taking all this time, but is actually effectively, operation A is consuming this T1 plus T3 plus T6, whereas operation B is consuming T2, operation C is consuming T4, right? So it's not the entire length of operation C, because some time is actually spent in operation D. So operation C here is just waiting for operation D to execute. So we can do that type of, because we have SQL, we can actually do that type of query that gives you, the detailed, the details of the time, the actual time that is spent in the trace. Again, I won't get a lot into the detail of how this is done. This is where you see subtracting, the duration is subtracting the sum of all the children, this time, the duration of the child spans. But I recommend you read the blog post if you want to look into more detail, dig deeply, because you will need a lot more time, to spend all the details. But if you want to spend more time on it and figure out, potentially all the queries and that you could run on the data to understand how your systems behave, I think that blog post is a great starting point to understand how this works. And so, just as a quick recap, before we wrap up, first, OpenTelemetry is a vendor-agnostic standard to instrument code with traces, metrics, and logs. I strongly recommend, if you're thinking about instrumenting your applications, I strongly recommend you look at OpenTelemetry. A trace, is a connected representation of the sequence of operations that were performed across all microservices involved in order to fulfill an individual request. So you get an understanding of how a request was executed end to end. PromScale, which is the product that my team builds, integrates seamlessly with OpenTelemetry to store traces in a Timescale DB database that is built on top of PostgreSQL. And because of that, you have access to full SQL. And with that, you can get a very deep understanding of your system. So it's not just seeing the individual traces, which is something definitely you can do really well with Yage. It's about doing aggregated analysis on the data, so you can visualize those maps, for example, that help you understand the behavior, the actual behavior of your system by querying the tracing data.
Cool. Just before we wrap it up, Ramon, Kenny, who's been watching on LinkedIn Live, has come up with a question. It's on the screen. You see that?
Yeah, so that is true. So if you're doing sampling, I should have mentioned that, and actually we mentioned that in the blog post. So if you're doing sampling, definitely the request rates would not be accurate, because when you do sampling, you're basically removing some of the trace data. And you do typically do that because it's expensive to store and query, all that data. So you try to get a representative sample of that. And obviously, if you do that, then request rates will be inaccurate. It only works if you're doing full. You're keeping all the data. If you're doing for error rates and for latency, the data may be more accurate, but it also may depend on how you sample. Because if you're sampling and maybe you're biasing towards just keeping those traces that had errors, then obviously you will get error rates that are higher than what the actual error rate is. So sampling is this mechanism to keep data, and there are different ways, there are different algorithms to decide what data to keep. If you just sample, let's say blindly, just 10% of all traces, then error rate and latency should be accurate. But if you don't, and you use some other type of algorithm that looks maybe at errors and whether a trace was slow, then those values will also not be accurate.
Yeah, he's just messaged as well saying, "Got it, thanks." So I think that answered it. We've referenced the blog post quite a bit during this session. So what I'm going to do for anybody listening or interested is I've just posted it in the chat. So whether you're on LinkedIn Live or YouTube Live, the link to the blog post should be there right now for you to be able to go and see in the comments. I'll post it on the screen, but it's a very long link. So, so it's in the comments for anybody that wants it. But Ramon, I appreciate the demo you've gone through. I think the amount of data that's available just by clicking through and being able to see things in real time, whether it's a second update or a minute update, are invaluable. But before we wrap up, we've spoken about the business this year. We've spoken about the amazing funding round, understood your job. What does the rest of the year hold for Timescale and for you personally?
Yeah, so for us, I mean, I focus more on PromptScale. So we definitely continue investing very heavily in the product. At the moment, we support, as I said, we support OpenTelemetry metrics, OpenTelemetry traces, and Prometheus metrics. So over the next few months, we'll add support for OpenTelemetry metrics as well. By the way, the standards are still sort of evolving. OpenTelemetry traces is stable. Metrics is, the spec is stable, but most of the libraries for different languages are not. I think probably maybe none of the languages have reached a stable. Logs is still in, being heavily defined and developed. So we plan to add support for metrics. Eventually, later, I don't know, this year, maybe next year, logs is our goal. We'll also add support for ingesting influx metrics later on. And yeah, a bunch of other capabilities like native alerting within PromptScale and other capabilities that will be useful for our user community.
Lots of exciting product development then.
Yeah. And we'll be, by the way, at KubeCon in May. So which happens to be in Valencia, so very close to where I am.
Yeah.
So if anybody is planning on attending or anything, we'll have a booth. So by all means, come by the booth and say hi. We'll be happy to meet you and talk to you.
I can't remember the last in-person event I attended.
Yeah, probably a long time ago.
It's too long, mate. So hopefully next time we speak, it won't be too long, but you might be the most active project on CNCF rather than the second most.
Yeah, I don't know. I mean, Kubernetes is ahead by quite a bit. So I think it'll be hard, to do. But yeah.
Yeah, absolutely. Well, look, it's been really, really good having you on. I've appreciated your time. It's been really informative. This has been streamed live, like I said, on LinkedIn and YouTube. For those that have missed it, it will go live on the platform straight after this as a recording as well. And just to sign off, Ramon, if people want to get in touch with you, how is best to contact you?
I think the best way to reach out to us is on our Slack community. So we have timescaledb.slack.com. If you join that and there is a PromptScale channel, that's probably the best way to reach out. Or you can search, you can DM me directly there. I'm Ramon there. That'll be easy to find. You can also DM me there. That's probably the easiest way for anybody to reach out to us.
Excellent. Well, brilliant. I really appreciate it. And hopefully we'll catch up again soon. But enjoy the rest of your evening, Ramon.
Yep. Thanks a lot.
Brilliant. Thanks, everybody.
Bye.
Bye.